Why is zero-shot prompting for code often irreproducible? Imagine asking a friend to write a piece of code without giving any examples or hints. Every time you ask, you might get a different answer. That's similar to what happens with zero-shot prompting for code. It sounds simple, but it can be quite unpredictable. When you use zero-shot prompting, you give a natural language instruction to a large language model, and it generates code based on that. But unlike traditional programming, where the same input always gives the same output, this method can produce different results each time. Why does that happen? Let's break it down. First, the way you phrase your prompt matters a lot. Small changes in wording or punctuation can make the model interpret your request differently. For example, changing a question from "write a function to sort a list" to "create a function that sorts a list" might lead to different code snippets. Since zero-shot prompting doesn't include examples, the model relies solely on its understanding of language and code patterns from its training. That means it guesses what you want based on how you phrase your instructions, which can vary. Second, these models are not fine-tuned for specific tasks. They are trained on a wide range of language and code data, but they don't have specialized training for your particular problem. So when you ask for a solution, it pulls from general knowledge, which can lead to inconsistent outputs, especially for complex or ambiguous tasks. Sometimes the model might interpret your request differently depending on its internal state during each run. Third, the way the model generates code involves randomness. It uses probabilistic sampling, meaning it picks tokens based on likelihoods. Even if you give the same prompt twice, the model might choose different tokens each time, resulting in different code. Unless you set the randomness to a fixed level, called temperature, the outputs will vary. External factors also play a role. If your prompt includes unrelated code snippets or errors, the model might get confused and produce inconsistent results. The context you provide can influence how the model interprets your instructions, making the output less predictable. Ambiguity in your instructions can also cause issues. Natural language is often unclear or open to interpretation. The model might understand your request differently each time, leading to different code snippets. Without explicit step-by-step guidance, the model jumps straight to an answer, which can vary depending on its internal reasoning at that moment. Finally, methods like chain-of-thought prompting help improve consistency by guiding the model through reasoning steps. Pure zero-shot prompts lack this structure, so the model may produce answers based on different internal assumptions each time, increasing variability. Knowing these factors helps you understand why zero-shot prompting for code isn't always reliable for reproducibility. To get more consistent results, you can give the model examples through few-shot prompting, control the randomness by setting the temperature to 0, or refine your prompts through trial and error. Using structured prompts that guide the model step by step can also help. Recognizing these limitations allows you to set realistic expectations and use AI tools more effectively for coding tasks.